Hello again. Right, I'm back again, and now what I'm going to do is I'm going to do a video on the probe part of this tester. It's now daylight outside, so it feels like I've been doing this for hours, but actually I haven't really. But anyway, so what you need is a standard probe like this, as you can see. You can get these in Maplin or wherever. They're not that expensive. It has to be a 50 ohm BNC and a typical oscilloscope probe tip. A ×1 is needed. If you do a ×10 it won't work, so really if it's got a switch on it like this one has, put it on ×1. So the first thing we need to do with this is plug it into the tester. So if I move this around, you'll see there's our tester. Yeah, again, try and get it lined up, and what I'm going to do is plug the probe into the BNC. And at the moment nothing's happening. It's on the digital probe as indicated on the last videos. And now what I'll do is I'll start probing some points on a board. Now I already have a board set up. If I turn this down, you'll see, some of you might recognise this as it's actually a Pac-Man bootleg board. This board actually works, and I'm using this just as a test bed, basically just to show you stuff on it. So if I start probing some points, you'll see what happens. All you need to do is just hold it on different pins. It's pretty easy stuff, as most of you will probably know, right? So if I hold that onto the tester, we'll show you what happens. So if I pick a point on the board, we'll go to there, straight away you get a figure. So what's happening here is you're getting 29 appearing. 29 is the duty cycle, which is the measurement of the time it's actively high and the time it's actively low. It's a ratio of the two, and when it gets to 100 or 99 it means that the signal is more or less all high. When it's actually sort of 0 or lower than 10, it's more or less all low. 29 indicates that the majority of the time it's low, and it's obviously going high on, 29% of the time roughly. This is the waveform pattern. So as you can see, there's two bars at the bottom and there's an upright peak, which indicates to you that it's actually an active high signal. So basically most of the time it's low, which indicates the two bars at the bottom, and because it's got a peak like that, it indicates it's pulsing high. Obviously if that figure's higher, then that waveform will change. It's still obviously a D. Now I can demonstrate that with my scope. If I bring that round here, you can see I'll hold it on the same pin and I'll put this onto the scope and you'll see the pattern. There you go, that's the waveform. As you can see, it's more or less all low and you've got pulses high, which is what this is actually telling you as well. So now what we'll do is we'll do another one. So I'll keep this thing there so you can see both of them, switch it back over to that one, and it's gone back to 29. If I go to another pin, you can see this time I'm getting 74, and as you can see, don't worry about the screen. If it times out and goes blank, you just touch it and it comes back again. The two bars at the top and the line goes low, so it indicates it's an active low signal. It's a 74% duty cycle. Okay. If I go to the scope, we can hopefully show that as well. And there you go. And you can see it's more or less all high, and the pulses this time are going low. It's not really dependent on frequency, it's more the measurement of the time, as I say. So even if it's a higher or a low frequency, it'll still come up with a duty cycle, etc. If I do another one, we'll do 3 just to show you what happens. So back onto that, you can see it's 74, which is the same pin. Go to another pin, and this one's coming up with 48. 48 or 50 is more or less a square wave, so when it gets to 50 it's a square wave effectively, and as you can see the waveform pattern has changed. You've got a bar, a line and a bar, so that is trying to tell you that it's more or less a square wave type pulse. So if I go into the scope, you'll get an idea what that's doing as well. So, well, unfortunately I have to change because the frequency's gone up, and you can see it's actually a clock pulse. So you can see it's not square wave, or it should be, but there's a bit of ripple in it and all that, but you can see it's more or less spending most of its time low and most of its time high. So the tester is actually displaying pretty much what the scope will do, and it's giving you a figure for it. The other thing you can do with the probe, we'll put it back onto there again, is it does work as a logic probe as well. So if you take it off, it goes back. If I put it on to say a ground pin, you'll see it will come up and measure low, so it will tell you straight away it's low, so that pin is a ground pin effectively. If I put it onto say a 5-volt pin, you'll get high, so it will show you high. So it works as a logic probe, but when obviously you get a pulse going into it, instead of a logic probe just giving you a pulse light coming on the green and red lights flashing, this thing will actually give you figures, so it's a little bit more accurate and also more informative. And the probe function is used in when you do the testing as well. When you do test programs and that, it uses that facility to actually identify pins for you. If I go into the analog, as I've said before, so I'll click probe to put it onto analog. So we changed it over now to analog, okay, and it's measuring nothing. So if I go onto ground, you see nothing. If I go onto a 5-volt, it's measured 5.02 volt, as you can see there. Move that a bit closer. There you go. So you get 5.02 volt, which is the voltage of that pin. If you put it onto a pin that's obviously fluctuating, like with a pulse train or something, you'll get a variety of different voltages, but you can see it does measure the voltage. So that's basically the probe. There's other things you can do with a probe. You can trace pins, etc. with the probe. I'll do a separate video showing that, because that's a little bit more elaborate and you have to type in commands for it to do it. The other thing you can do with the probe, as I say, is an audio amp. The noise in the background, by the way, is because there's a mobile phone nearby and it picks it up. But if you see, there's the probe. There's an audio amp now hooked up. And again, if you turn it off, it's off. Nothing happens. Okay, go back to the digital. So it's back onto digital. You can do the audio amp on that as well. You get a wee bit of noise with the digital. The amplifier is reduced a little bit because the probe is biased when it's on the digital. The tip of the probe floats about 2.5 volt, but it's fed through quite a lot of high value resistors, so it won't affect any circuit you probe, but it requires a bias voltage so it can detect the levels. It's a tri-state, so it will detect open circuits, low, high, etc. So it needs to have some bias on it. So the audio amp is reduced a little bit when it's on the digital. The analog, there isn't any biasing. Okay. And that's pretty much the probe. So thanks very much, and the next video I'm going to do is where I hook it up to the Pac-Man board with the processor socket, and I'll show you how we can read in some ROM data, etc. and do CRCs. Thanks so much.